Hello everyone, if you're watching this, you missed day 2 of our week 9 lecture. Let's go ahead and get going. So today is a very short lecture because I wanted to make sure you guys had some time to work on your assignment 12, the Bridge Research Project. Please don't forget, this is due Wednesday the 14th, and let's get started. So today we're talking a little bit about earthquakes, which are an interesting example of a very extreme stress load you might want to account for in your building, especially if you're building somewhere like California. So for our warm-up, we started looking at this very interesting case. This is a tower that has been built in the 13th century and survived several earthquakes. And the question is why? Well, you might have some guesses to start with. And then it's interesting to look at, first of all, how earthquakes work, and second of all, what we can do to mitigate them to then better answer that question. So this is a demonstration. I'm not going to play the whole thing for you, but I highly recommend you watch the video on your own. It's posted in 9CPS. But real quick, this is the boss model, and the idea is if you shake this very slowly, the large, taller building is going to sway, while the other two don't really move that much. Then you can change the speed of your oscillation to make just the middle building shake, and then if you shake it really fast, just the small building will shake. So the takeaway here is not all earthquakes are the same. It really depends on how quickly and what frequency the ground is shaking at, and that's going to change what buildings are affected. This is a great video. I highly recommend you watch. Again, I'm not going to play it for you here, but this is how buildings survive earthquakes. And there's several ideas. They're recapped here as well. So one thing you can do is you can separate your foundation from the ground by having some kind of moving foundation underneath that's flexible and allows your building to bend with the waves rather than having to sway the walls, which would be, of course, usually very destructive. You can have a large counterweight at the top of your building, and as the building sways, the counterweight will swing the opposite direction, preventing as much of the force from damaging the building. You can create essentially a shield around your building using concrete and plastic, and the idea is the vibrations will have an easier time traveling through these more rigid materials, and therefore avoid the building mostly. Having what's essentially a truss-like construction inside your walls will keep your walls from crumbling. So this won't prevent the building from being damaged, but it'll prevent your walls from collapsing, thereby keeping the people safe. You can separate the floor slab from the bottom using these columns on a horizontal frame. And the idea there is you can distribute the force a little bit more evenly along the wall. And last but not least, you can have these moment-resisting frames to keep the joints rigid. So you have essentially what is like a force damper inside here. And as the structure sways, it has a little bit of give to it. So these joints don't collapse on themselves, but they also don't crack as easily. Lastly, it's important to consider what kind of material you want to use. Do you want to use wood because it's lightweight and flexible, or do you want to use steel, and do you want to account for how it might get deformed? So you might want to create essentially a little bit of a weakness in your steel structure so that it crumples in just the right way to stay upright. So all of these are considerations. So hopefully thinking about all of those things, you now have a better idea of what may have gone on to keep this tower standing up. I'll let you fill in the blanks there. And hopefully you're doing well on assignment 12, your bridge research project. If you have any questions, please feel free to email me. Thank you, and I'll see you guys in class.